So in this video, we're going to continue topic 5.3, which is solving linear quadratic systems. We're going to work on explain to example 2b. And hopefully you've kind of realized that these are not short problems. It's not that they're super, super hard, just there's a lot of steps to them today. All right, so the nice part about this one is it's already solved for y for us. So I'm just going to literally take that and plug it in. So I have 3x minus 2 times, I'm plugging in the 1/4 times x minus 3 squared, and then that's equal to 13, okay? So the first thing I notice about this is that 2 is going to go into 4 twice. So I'm going to just keep writing down 3x minus 1/2. And then I know that this squared means I need to write it twice. So 3x minus 3 times x minus 3 equals 13. Then we're going to FOIL this piece here. So 3x minus 1/2 times x squared. X times negative 3x is negative 3x. And then I have another one of those in the middle, so when I combine those together, I get negative 6x. And negative 3 times negative 3 is positive 9 equals 13. Then they were kind enough to give us this fraction here, so I'm going to distribute that fraction in. So we get 3x, then negative 1/2 x squared. Negative 1/2 times negative 6 would be positive 3x. And then negative 1/2 times 9 would be negative 9/2 equals 13. Then I'm going to do something to get rid of the fraction. So this is kind of like a little mathematical way to get rid of the fractions. I'm going to multiply everything by whatever the denominator is to get rid of. So my common denominator is 2, so I'm going to multiply everything by a 2. So we're going to distribute the 2 into everything, including the 13, okay? So 2 times 3x is 6x. 2 times negative 1/2 is just going to be negative 1x squared. 2 times 3x is 6x. 2 times negative 9/2 would be negative 9 equals, and then 2 times 13 is 26, and woohoo, the fractions are gone. Now we're back to solving a quadratic the way we normally do, and I'm going to combine like terms and get it equal to 0. So I am going to put together 12 or 6x and 6x, which is going to be 12x. And then at the same time, I am going to subtract the 26 to the other side, which is going to give me negative 35 equals 0. The other thing that I would be really handy is if I didn't have that leading coefficient of 1. So I'm just going to divide everything by negative 1. As long as I do that with everything, I don't change the equation in any way. So I'm basically swapping all my signs. So x squared minus 12x plus 35 equals 0. Now I'm down to something that's very familiar looking. I'm going to go ahead and try my magic x. So my magic x, I need two numbers that multiply to 35 and add to negative 12. And I believe that that would be negative 5 and negative 7. I don't have a leading coefficient, so I just get to do I don't have to do the box. So I have x minus 5 times x minus 7 equals 0. Then I'm going to take each one of these and set them individually equal to 0. So x equals 5 and x equals 7. Now, I'm supposed to be solving a system, which means if I have an x value, I also have a y value. So I need to plug these in up into this equation up here, one of these equations, and solve it. I'm not sure which one's better, so I'm going to use this one just because there's no fractions. And I'm going to have 2 points because remember we could intersect in 0, 1, or 2 places. So my equation is 3. I'm putting in, first of all, an x value of 5 minus 2y equals 13. 3 times 5 is 15. I'm going to subtract the 15 to the other side. So I get negative 2. So y equals, when I divide by negative 2, 1. So one of my points is 5, 1. I'm going to do my other value, which was a 7. I didn't plan well on spacing here. So 3 times 7, right? Let's make sure. Yep, 7. Minus 2y equals 13. 3 times 7 is 21. Minus 2y equals 13. I am going to subtract the 21 to the other side. And I get negative 8. And then I've got divide by negative 2. So negative 8 divided by negative 2 is 4. So my other point is 7,